It's nice to see you again this week. I was actually looking forward to this week's class, and I was secretly hoping that you would all show up again this week. Because, I guess 4 weeks ago we talked about a topic which was horrible, no developer wanted to learn or do. That was debugging, if you remember. Like, basically every developer sucks at debugging. So it is what will set you apart. If you can get good at debugging, then you will be the star in your organization, even if you're a junior developer. Because that's a different skill set than developing an application. Actually, trying to see or assess or feel where the bugs might occur is different than being able to write an application. So that was a frightening topic that a lot of people struggle with. And the next one is testing, which is the topic of this week. It is horrible. Nobody wants to write tests. Every developer hates tests, and they don't therefore learn how to write good tests. Test-driven development is one of the best practices of software engineering, or at least writing some tests. If you ever heard the terms code coverage, line coverage, or functional tests, unit tests, or integration tests, end-to-end tests. There's a whole topic, and unfortunately it's kind of an academic field of study because, mostly the practitioners of this field, software engineers, hate testing. Therefore, teams, companies tend to hire QA engineers. Any QA engineers here? QA means quality assurance. So usually there are QA teams within software teams to test the output of software engineers, either manually or by writing automated tests. Are you writing any automated tests? Are you manually clicking through stuff? Yeah. So that's the first process. Like, the first hell that a QA engineer goes through is every time there's a new build of the system, every time there's a new release of the software, they go around and click on the web page, or if it's a mobile application, click on buttons, try to break the release, the application. And then at a certain point, this gets out of hand. So companies decide to invest in automation. So they start writing automated tests so that finally the QA engineers have some way out of that hell, let's say, a path that at the end where they see light. Automation is key to everything. But this happens only because the developers are too picky about the job that they're doing and they're not writing tests. And if you ever go to a job interview, you are sure to hear this from the interviewer. Do you write tests? Do you have any test experience? Every interview at every company asks this, and you almost always have to lie because you don't do tests. Nobody does tests. They don't as well. Like, they don't write tests, but they ask it in the interview because it's something, like a secret code, let's say, to software engineering interviews. That exchange has to happen. If you ask them, well, I don't write code, I don't write tests, but do you write tests in this organization, or do you have test-driven development? And they will surely say yes. And they are, of course, also lying. This is something accepted by the whole software engineering society, which, again, everybody acknowledges that it's a best practice to write tests, automated tests, and even test-driven development. And I'm going to tell what that means in a few seconds. But people hate doing it. They don't do it. Therefore, it's another chance for you to shine in your organization. When you land a job, or even if you're working right now in your current organization, if you are good at writing tests, if you have what it takes to know how to write good tests for your application, or further, how to structure the application so that it's actually testable, that's another step. Basically, you will again be the go-to person in your organization, in your team, for writing tests, which means it will give you more power. The more knowledge you have in your team that the other engineers or other people don't have, the more power you have. So the more indispensable you will be to the team, which is the key at maintaining your position, or let's say hopefully improving your position within the organization. Therefore, our hunger for learning for more. If you know more, you are at a better position and people are indebted to you because their team leads force them to write tests. They don't know how to write tests. So you help them, you save them, and therefore it's the start of a healthy relationship with your colleagues as well. Okay, so again, this is one of the hardest topics in software engineering, not because it's hard, but because nobody likes to do this. Nobody wants to tackle this. Since most of you are just new to testing in software, I hope you will accept it with an open heart and an open mind, that it's not that bad. And actually, if you know the right approach, it's sometimes also fun. And it saves you a lot of time and a lot of headaches, especially when you have a product in production, in live, that customers use. It saves you huge efforts of trying to debug or fix your bug in production, where maybe nobody is able to buy your product, and every minute you spend, actually the company loses money. It's a terrible situation to be in, and automated testing is a way of dealing with this, to make sure that those bugs don't occur even before you release that piece of software. So anybody familiar with software testing here? Raise your hands. Okay, quite a few people. Let's share some experiences. We have a couple of minutes, like 10 minutes, that we can share our experiences about testing. It can be anything, what you know about testing, or a certain case that it saved you, or a certain case that it hindered your progress. It was just a waste of effort and time. I don't know. Tell me something about your experience with testing. You smile a lot. You look like you have a lot of stories to tell.
Well, basically, I try to focus on simplicity.
Mm-hmm.
And for me, testing is checking if a certain acceptance criteria is passed or not,
Uh-huh.
available or not. So if we define the acceptance criteria in a very, very simple way, we can also check it relatively simply.
Okay. So make the tests as simple as possible so that monkeys can run it. If you can do this, it will be perfect, right? Then you can have...
If you can simplify it, there is no problem.
Yeah, of course. That's actually the key. And people make it very complicated than it should ever be. Also, not only in acceptance testing, but in unit testing or integration testing as well. And hopefully I will be talking about those instances today.
And the problem is often that when we are very complicated tests or a big amount of them and they fail, it's often because they fail not because the software is not working, but just due to changes.
Yeah.
So it takes a lot of time to go through all the tests and check, is the software not working or just the tests are getting too big. And mostly it turns out that
The tests are not updated.
because of changes, but the software is working.
Yeah.
And this is a lot of time.
Yeah. So this actually ties to the complexity problem. The tests are currently in software, and that's why people hate writing tests. It's so complicated that people lose track of their changes and their tests because you have 1,000 of them, and you are forced to deliver products and features and values to the company in a sprint in a 2 weeks time. And then, of course, you don't remember which tests are affected or will be affected by your changes. And if it's not automated, then oh, that's terrible. Like you click through something, you see that it breaks, but the developer tells you that it's actually working on their machine, and you know that it's kind of working, but the tests fail for some reason, and then you have to go back and refactor. You now don't debug the software, but you debug your tests, which is due to the amount of complexity is just disgusting. So the way to prevent that is to be intelligent about designing tests so that they are simple. Thank you. On your what? Yeah, yeah. It has to be both. And that is the dream of every manager. That's why they unfaithfully push their developers to write tests and to make it, as unbreakable as possible, but it never happens. Any other experiences with testing? Please, I saw like 8 hands. You have to have some experience, please. Yeah. Code retreat. Yeah. The game of life. Yeah. So you wrote tests for game of life. Mm-hmm. Mm-hmm. Yeah. That's actually very, very helpful. Especially if you have to deal with an algorithm like the game of life. Do you know what game of life is? It's one of the, let's say, the first entry points into interesting software engineering. It's a piece of code that you write. There's a grid. There are some cells that light up, and when there's food in the nearby cell, there are some rules that so you grow kind of. Cells turn or switch their colors based on proximity to other cells, kind of. And it's fun to program. So you can check it out, Game of Life, JavaScript implementation, there are a lot. And there are very well-defined rules of how it should function. And therefore, if you have an algorithm that you have to write code for, it's good to start with some use cases. What are the example inputs of that algorithm, and what is the expected output? If you know that, and in Game of Life you do, and in every algorithm that you design you should know, if you know that, you first write the tests that ensure those inputs and outputs, and then you write the source code. And one by one, you see the tests are passing, tests are succeeding, and that actually gives you another boost motivationally because you see, yes, I'm doing this, and you know that you're doing it correctly because you wrote the tests first. Otherwise, you're developing for like a day or two, and then you are unsure if it works at all. Yes, of course, you have some console logs or you check some of the features some of the time, but not all of the features all of the time. And why not write it once and run it on every change so that your tests ensure that kind of you didn't make a mistake, but that's very tricky, and I will talk about that later. There was another experience there. You don't really like your tests. That's normal. Nobody likes it. You don't know how to do it yet. So hopefully we will learn today. Yeah, wait, back. Okay. Yeah. Yeah. There are other countermeasures for that. It's helpful, yes, as a beginner. Yeah. It forces you to think. Yeah. Yes, it forces you to think and structure, or it forces you to think in a structured way, let's say. Because everybody's thinking, of course, when they're writing code. But the problem is they don't think in a structured way. That's why we have a mess. You know, they start with something that's working. The second step also works. The third step also works, but then they break the first step because they don't have a structure there. Any other experiences that you want to share about testing? Okay, now I want another person who was just exposed to testing. How does it sound from the experiences you just heard? That's the question. Raise your hand and tell me how it sounds, how testing or software testing sounds based on the stories that you just heard. Just very simple. Sounds terrible? Okay. Another opinion. And it's fine, of course. Come on. Just tell me something. What? A meticulous work, that's right. There's only one person who likes to write tests.
I love writing tests.
Why?
It's it's so amazing. I think it's probably because I come from the Java world and it's so heavy to just start an application, especially so if it's so enterprising. So if I write a unit test and I know that something I'm writing works, when I'm going to actually start my server and everything, I have like a I don't know 90% security that it's already gonna work.
Yeah.
And then it's so like amazing and beautiful when you get into the cycle of writing a test and then writing the code and then you just continue like in a cycle and then you push your code and then I don't know you realize that I don't know you broke someone else's functionality and there and you think that there was a test that told you you broke something else.
Yeah. It's really important in collaboration and also in the open source world. That's why a lot of open source libraries have tests, but not the commercial applications. Because there is a disconnection between communications of two open source contributors to the same project. It's just random people, right? And obviously, if the project is above a certain size, you may be fixing some bug and you may be contributing a very tiny feature to the library or to the open source solution, but you may be breaking other things and you can never be sure. But if the open source project has enough tests that cover most of the use cases, at least that tells you something that you didn't break anything, so you're good. So you can submit your change set, and the maintainer of that library is another person like us, so it's not their full-time job. So they do it in the evenings for free. Therefore, you cannot expect them to manually click through everything to make sure that it works. So it's another, confidence mechanism for them to make sure that their code or their project is still functioning as it is, although they took in some code from a third-party developer, from an unknown developer. It's like a virus trying to infect the body, but they know that the defense system is really good, so it's actually not breaking anything. Therefore, most of the serious open source projects will actually require you to write tests for your change set. If you're proposing a new change set to a project, they tell you that it's not enough to just write the code for it, for the new feature, but you also have to write the tests to prove that your feature works correctly, and also in the future that other people won't break your changes. Okay, I want to get back to the idea of that lead who says test-driven development is an ideal and the reality is different and we have no time, which is actually true. Please.
Test-driven development is more a design process rather than anything to do with testing. And I think it's very better to try to use it. And especially because what you mentioned about writing unit tests is not something that testers or QA department does.
Yeah.
And that should be
Yeah.
So my experience would be, extracting from my experience, we never worked for a company which has a testing department or a QA department.
Uh-huh.
Like they don't know what they're doing. So that's one thing you can learn from me.
Yeah.
But testing itself is very, very important, and it's more about design.
Yes. So I want another person who just learned what testing is today to tell me what they think test-driven development is from the conversation we just had. Raise your hand and tell me what you think it means, test-driven development. Obviously not the people who know it, what it means. Come on, we're just chatting. It's all right. Yeah, it's when you write the tests first and then you develop the features to actually satisfy those tests. That's why it's called test-driven. Tests drive your development. They dictate you what to develop and the order that you develop. And the idea is no single line of code is written unless it has a test. So you first write the test, and then you may write the functionality. It's too easy to say, oh, it doesn't matter. I actually like this is a very simple logic. What can fail? I will just write it. I don't need tests for it. And then you just write the functionality. And that's fine, that works. But 10 months later, another developer comes in, and your simple functionality is now a giant mess because a lot of people contributed to it in the last 10 months. And then they make a very simple change, seemingly very simple, and then the application just breaks. But nobody knows why it breaks because there are no tests. If you just took the effort before and wrote tests for it, everybody would have a comfortable sleep at night, knowing that it won't break whatever we do. But again, coming back to that problem of time, of reality, yes, that is true. Like, I also lead a software engineering team, and I also say, hey, the reality is different than the ideal, so we don't do test-driven development. And I'm honest enough to admit this during my interviews to the candidates. I say, hey, we don't do test-driven development. We try to write tests as much as we can to make sure that we get at least a level of confidence with the code, but we don't do test-driven development because it's really hard. In fact, I don't do test-driven development for my open source projects as well, which you could think, hey, like you have infinite time. There is nobody pressuring you, right, to develop something. So you could take all the time to do test-driven development properly. But then I will explain some reasons later. But then you also want to spend some time for yourself. You don't want to spend all your free time writing code. So there's another time pressure there. You want to get results out there as fast as possible because you have ideas in your mind that you want to share with the world, and they cannot wait. Therefore, even on your open source projects, it's kind of impossible to do test-driven development psychologically, but you at least have some tests, have some stable tests. Another idea about not writing the tests first or writing the tests first, it actually really helps junior developers and beginners. If you write tests first, it forces you to structure your thoughts. And once you learn that structure, actually in real life, you can skip that step of writing the initial tests to do test-driven development. So you can actually skip to development directly because you know already how to structure your source code. But obviously this happens, third year, fourth year, fifth year into your career. It's not something that will happen in a few months. But then you can actually skip test-driven development and move to writing tests after you develop the features, which is also still valid, as long as you make sure that the features are covered. There are different methods of testing. So the first one, the simplest one, let's say, or the one at the core is called unit testing. And the idea is you take a unit of your source code, which could be a function, a class, a group of classes, hopefully not that big, but a small unit chunk of your code, which should be testable. You give it inputs, and you expect an output. And for example, the addition function, that's a unit of code, a function that adds two variables or two numbers. Well, you want to test it, and it's called a unit test because it's a small unit of code, and you give it various inputs and check the output. If I give it 1 and 3, is the output 4? If I give it -1 and 3, is the output 2? What happens if I give it -0 and +0, for example? Or what happens when I give it -infinity and 3? I don't know. You first define your test cases, your example input and your example output, and you just make use of some tools that I will demo in the coming hour to automate these running of these tests, these inputs. It's like you writing a function and then calling it manually with different inputs to see that it works. So the property or the significant feature of unit tests is the code that you're testing shouldn't be depending on any other module. Okay? So if you are testing the function add, that add function shouldn't depend on any other unit or any other module or a database or a file system. It should be a standalone class or a function that you can run anywhere, anytime, that doesn't interact with the outer world. If there is an interaction with the outer world, like a database, or for example, if you are doing a call to another web server to get some data from that, that is a different testing methodology, which has very different names, but let's call it integration testing, because you're testing the integration of two different modules, and you have a dependency. If you have a dependency in a test, you already forced yourself into a very, very difficult situation. Let's say that dependency is a file system, all right? So you're writing files to a hard disk, which is a resource that you cannot really depend on, which may be gone, which may be changed by other people, or even by your tests that try to run simultaneously, or a database. So your code, for example, the person models that we have, depends on a database, right? When you create a person, we write it to the database. So it's an integration testing when you want to test that person model. What happens is you have to make sure the database is in a sane position that you can write to it and read from it, and no one else will break your tests or records. It could be the case that when you're testing, you write something to the database and you try to read from it, but by the time you do that, that record is gone because someone else is just messing with the database. Because you're using the test database and you have test users who are already interacting with your app, which is crazy, but happens a lot in real time, in real life, which is really, really hard. So people came up with the idea of a mocking. Do you know what mocking means? It's a real life term. Of course you know. You write tests. Tell me what mocking is. And mocking a person, or yeah, please. Making fun of somebody by doing by kind of imitating them. That's the idea. So Trump mocks a lot of people by trying to imitate them, their sound, their voices, their moves. So the idea of mocking is, if you have a database, you mock the database, and that creates kind of a dummy database so that your application thinks that it's talking to a real database, but in fact you have mocked it so it's just talking to you, like a straw man that you built and put in place of the original database. That's called mocking. So you make sure the calls to create a record in the database don't really hit a real database, but they're mocks, so that you can check. You know, for example, in Mongoose we have the create function, right? Person model.create creates a record, or person model.find actually fetches some records according to the criteria that you passed in, if you remember, from E5. So the idea of a mock is you say, I want to know how many times the find function or method is called. I will mock the database, so there will be no real calls to the database. But since I mocked it, I can actually count the times that find function is being called, or that create function is being called, because I now am acting like a dummy database. So all the calls that is supposed to be going to the original database actually end up in my mocks. That's what it's called. Or stubs. Stubs also is another name. Stub is another name for mocking. So people tend to convert integration testing into unit testing by incorporating mocks or stubs for dependencies. And another layer, so the first layer was unit tests, the second layer was integration tests, and then there's the third layer, which is called end-to-end tests. Again, tell me what you think it means, end-to-end tests. Raise your hand and tell me what you think it means, end-to-end tests. There's a hand there in the back. Yeah?
Well, maybe it's taking your application all the way to the entire all functionality.
Yes. Exactly. Think about your homework or what we did up until now. You know, we have a backend application, and from the front end, we are writing some axios.post or get some code, right? That is actually an end-to-end test. So we have the application is the backend application that we wrote, and we're actually testing it from the front end, from the browser. It doesn't have to be a browser, it could be anything, it could be another backend application. But the idea is you don't ever touch your application, you don't break it down to pieces, you don't test it piece by piece, but as a whole. And you do it by utilizing your application like a real user. You know, if we had a real front end, a web page, or a mobile application that talks to our backend API, it would use the same calls that we used with Axios. It would do a post to /person to create a new person, right? It would do get /person to get, or /person/3 to get the details of a person, right? And by acting like a real user, you basically test the end results of your application. So your whole application, in fact, becomes a unit, and you have some inputs, like you want to create a user, and you feed it to your black box system, and you look at the output. That is actually how we developed it in Chrome when we wrote the Axios calls, to check if we could create that person, if we could make them friends, if you remember again from the previous weeks, right? We implemented that functionality, we did the same call again from the front end, and we tried to see if they could make friends. This is basically what end-to-end testing is. And I actually give it another name because end-to-end testing doesn't really tell you how to do it. I call it automated user acceptance tests. That is what we follow at UNU with my company. And it's actually what a lot of other companies do manually, we automate it. So every task that you are required to develop should come with something called an acceptance criteria. An acceptance criteria is a list of steps that a person needs to go through, or a machine needs to go through, to ensure that that functionality is implemented correctly. Like making friends. How do you know if you can make friends with a person from an application? Let's think about Facebook. You go to their profile, you click the connect button or make friends button, I don't know. Send friend request, that's it. And the other person has to acknowledge it, and then you're friends, right? These are the steps that you have to take every time you want to test this feature. So the idea is to automate this with software. And on the API level, of course. Think about the make friends with API that we did before. Create a person, create another person, call the friends API that we wrote, the friends route, if you remember from the previous weeks, and that should make them friends, right? Get the details of user one again, person one again, to see if they are friends. This is exactly what we did with the front-end code that we wrote in Google Chrome. We wrote Axios post and we created a person. We again wrote Axios post, we created another person. We made the first person friends with the second person, and we asked for the details of the first person to check if they are friends, if the document is updated, right? So you can actually automate this. And I call it automated user acceptance testing. So the developer actually doesn't come up with those steps. Those steps are defined by a product manager. A product manager tells, hey, I want to test the functionality of making friends. And they say, you know, I have person A and person B, and I click here, and they should be friends. A developer comes in and translates this to API calls. Developer says, okay, I need to create a person first, another person, and there's the API that actually makes them friends. It has a URL, and it accepts this input, you know, target ID and person ID, if you remember. And then I check the first person to see if they are friends. So after that, you program this. The developer programs this once as a test. And then, you know, every time you make a release, you basically run this, this whole 4 steps. And it makes sure that your application has making friends feature. Now, I will show you that how you could do this with unit testing, starting from the person model and working upwards to the endpoint, to the HTTP request that we're doing. But I want to underline a metric called the value proposition, or simply the value that you get out of testing. In the end, we are writing software at a company because we want to turn an investment, which is money plus time, or mostly time, into money, right? We want to generate money by creating a product, by selling a product, by developing a product. That's why we do software engineering for a company. And the idea is every minute you spend is actually has an opportunity cost that you don't spend on something else. So it's also true for testing. That's why in real life people don't do test-driven development, because it unfortunately takes, or at least you think it takes, more time in the beginning. Therefore, they skip tests, they fail in production, they spend more time debugging it. Actually, it's 15 times. So 1 hour spent in test-driven development saves you 15 hours in bug fixing. So it's a good idea to do test-driven development, but still nobody does it, unless you're very idealistic. And there are some companies who are very idealistic, by the way, but it's impossible to work there because the competition is huge, basically. But the idea is, if you have limited resources, you have to optimize them. You have to make the best use of your resources. Therefore, of all these testing strategies, you have to pick 1 or 2, which gives you the most value for your time. And I found it to be these automated user acceptance testing because it's very simple to write. There is no complication. You just use the same APIs a front-end application or a mobile application would use. And you just look at the output. You don't care how the system is built. You treat it as a black box. Maybe internally that system is wrong. Maybe internally there are 1,000 hacks and 1,000 wrong implementations to give you the correct result. But as long as the result is correct, oh, did this die? I guess so. Anyway, as long as the result is correct, you basically don't care, right? Or you shouldn't care. How does that sound? It's pragmatic. We have some dead batteries. Do you have some more? Thank you. But that is the reality of life. You have to optimize every minute of your life, and that's true for testing as well. So if you can treat your application as a black box and just look at the output, why do you actually deal with the details? Yes, of course you can go and do integration testing. Of course you can do unit testing to test every single function in your code with 100 different types of inputs. But would that actually mean a lot for your application? What value would it bring you? Because the biggest problem with unit testing is, you test individual parts of an application. You test, thank you. You test individual parts and individual functions in the application, and they all seem to work perfectly. They all do the job that's given to them, but in the end, you look at the output of the application as a whole, and it doesn't run, it doesn't work. Because the connection, the glue logic that brings those functions together is somehow wrong. Therefore, you spend a lot more time in unit testing to get the same confidence level as end-to-end testing. So people tend to do end-to-end testing more, please.
It also depends on the application that you are building, right? Because I work for a company that had a lot of integration with external systems, external services, and so we did a lot of unit testing on like the parsing of the responses from the external services. And since that was kind of the core of the application, like we were nothing without actually getting the data right.
Yeah.
And we had a lot of unit testing there.
So this is a very good point, and I would like to address that. So the idea is when you're working for a company that works with a lot of third parties and that has a lot of integrations, like for example, you're building an e-commerce application and you have 10 different payment processors like PayPal and Stripe and other companies that you have to work with, or 10 different payment methodologies like bank transfer, credit card, etc., that you want to work with. It means you have to write a lot of code for integrating your solution with other solutions. And the exchange is basically through some APIs and some JSON documents, just like we did with Axios when we received the JSON documents. You send, for example, the credit card details and the amount that you want to process, and then they send you a confirmation, hey, it's right, it's okay, kind of like this. So you have to make sure that the third parties are actually doing their job right. You have to make sure that your application can talk to the third parties. But this is a very crucial point where every single company that I've seen so far fails, is they treat this as a unit testing problem. And when they treat this as a unit testing problem, if you remember the mocks that I've talked about, when they treat this as a unit testing problem, there should be no dependencies, right, in unit tests. But the idea is to test a dependency, because you're depending on a third-party payment processor, so you want to test it. What do you do to get rid of dependencies? You mock stuff. Therefore, this leads people to mock external dependencies. Okay? For example, they mock PayPal, or they mock Salesforce, or whatever the external dependency is. What is mocking in this case? They imitate that service, they imitate the responses of that service, okay? And they write their code to see if they could parse the input. And they write, hundreds of tests to make sure that at a certain given time, their code works for all the use cases or all the example responses that payment processor could give you. And it takes 3 months to do that. And it works. It works perfectly on the day that you finish those tests. And 2 months later, you get some bugs from your customer support that says, hey, payment doesn't work. PayPal doesn't work anymore. And you're like, this can't happen. I wrote all the tests in the world that I could think of. I spent 3 months on it. And all the tests are passing. What is the problem? The problem is you mocked it. The problem is you mocked the dependency because you didn't want to depend actually on that thing for testing, because unit tests are meant to be run every time you make a change on your system, which means they have to run locally on your computer, which means they have to run very fast because every time you save a file, the unit tests should run again. So you cannot afford to wait 20 minutes to run the unit tests before making another change. And you cannot afford to make an API request to PayPal, for example, or your payment processor, because they're actually charging you by the API requests you make to them. Therefore, you have to mock them in your tests. And then they just released a new version, some fields changed, so your software is incapable of parsing those new fields. And although every single one of your unit tests pass, your system doesn't work. This is a very nice example for that. Therefore, it's never a good idea to mock something. If you see any mocks in any tests, you can say, hey, this is a red flag, you're doing something wrong, and we should change this. Either we should refactor our source code so that it doesn't depend on the dependency, which is not the topic of this course, but it's a very advanced topic, and it's, again, something that only very few people can do. But you either refactor your code so that you remove the dependency and you can unit test your code without that dependency, and it's possible, or you just don't. You don't treat your integration tests as unit tests. That's the idea. It's called an integration, right? It's not a unit test. You cannot mock them, mock your dependencies, and try to simplify it, let's say, or make it easier. But you can do integration testing, which happens with real requests, which is something you cannot run every time you make a change to your source code, which forces you to be more careful when you write your code. But at least you make sure you are not imitating a dependency. And whenever you're running your tests, you're dealing with the real service. Therefore, if there's a change in the real service, in the real dependency, like the payment processor changed a field, your tests actually fail because they depend on the real dependency. They are not something that you made up. They are not mocks. So you interact with the real thing. And if the communication changes on their end, it breaks your tests. So this thing doesn't go to production, which is, more valuable than spending 3 months to generate mocks and try to cover every edge case, every use case. No, just spend maybe a week or something to actually test the endpoints that you will use in your real application and just make sure that it works in a test environment. I mean, every integration comes with a test environment, whether it's a payment processor or a bank or any API provider, like even the weather APIs. When you sign up to use a weather API to get the weather based on a location, it comes with a test server, a test system. Yes, of course, it still has a API request limit, but that's where it drives you to be more intelligent and to be more cautious. So write your code in such a way that you don't need mocks, that you use the real dependency, and just test the endpoints that you use. It doesn't matter, again, if you call the payment API on your own system, on your own backend, and somehow you are able to make a purchase. It doesn't matter if there's a wrong field, if there is, something broke, or there's a bad implementation within your system. It doesn't matter. As long as you get the right output, that's all you care. As long as your mobile application doesn't fail, that's enough. So what you need to do is mock all the APIs, public APIs that people use, that people will use, with as much input as possible to test your application. Another very limiting factor in unit tests, and again, this is something maybe 95% of the people do in software engineering, is basically they use predefined inputs. Okay? So for example, for payment, they may test with minus $30, $30, $0, $100, okay, stuff like this, for the price, for example, of a unit. And they say, okay, like, what can it be? I've covered all the cases, right? I'm an intelligent software developer. There can be 5 different edge cases, and I've covered all of them. And these are all the inputs that I ever need to test this thing. This is one of the biggest mistakes people do, because real-life users, and there are millions of them, hopefully, using your application, they are not intelligent. Therefore, they always find ways to use your application in the most wrongest way, worst way possible. They make sure that your application breaks. They come up with so crazy inputs that you could never ever even imagine. Therefore, it's impossible to trust yourself to come up with all the edge cases that you can find for a test case. But what you do in this case is, again, this is only something like 5% of the people in the software industry do. You use generated input. You use random inputs for your tests. If it's about the price, okay, just use 2,000 random numbers between minus infinity and plus infinity. And if it's a name field, use just random garbage text in every language that you can imagine. Don't just assume that people will write in Latin characters. Try Mandarin, Chinese, or any other language that doesn't conform to the Latin alphabet as input. Just put random text. It doesn't have to be real names or stuff. Just put random text and see how your application actually works. And nobody does this, especially with string input. Nobody uses random input. Therefore, if you see a social network in its infancy, you always notice that foreign characters to the Latin alphabet are always displayed as boxes. Because actually nobody bothered to write the Kirill alphabet, or Cyril. How do you call it? Cyril or Kirill? The Russian alphabet. Cyril? Cyrillic? Yeah, Cyrillic. Yeah, so nobody just ever imagined to write in Cyrillic their names. Or, again, Chinese. And therefore you all get boxes as the output. What you can do in this case is just use generated random inputs to simulate the millions of users who will hit your application in very interesting, let's say, ways. Not dumb or silly, but interesting, to be politically correct. And if you do this, then, and if you see all the time that your application actually works with random input, it gives you another level of confidence, because you as a human are not as intelligent as you think you are. So you cannot come up with all the edge cases to test a function. So it's a good idea to, of course, have some predefined input, but it's a good idea to just test your software with just random input as much as you can to make sure that it works in every use case. This is an emerging trend, especially in testing as well, generative testing. And people started to write articles about this thing. There are some frameworks on the market which create random input, seemingly random input for your unit or integration tests. And this will be the next big thing in testing soon, because this is actually what brings you the most value. As an engineer, you are very limited in capability to come up with edge cases again, or different inputs, but a computer can generate billions of them in a second. So it's always a good idea to put the computer to use to work for you. So especially for algorithms, if you are designing an algorithm, make sure that you have random testing that with random values. And you don't have to even check them, but there is the confidence level. You can say, I need 200 different random inputs for this function, or maybe 1,000 for the other function. Just, for a single function, instead of writing 200 different inputs by hand, you generate them and you test them. And when all the tests pass, it gives you a level of confidence that you couldn't have before. Because now you have numbers from -infinity to +infinity. And you tried all the characters on every alphabet, which you couldn't do manually. So it's always a good idea to automatically test your source code. Do you have any questions so far? Oh, a lot, please.
I'm still not sure what the difference is between integration test and end-to-end testing.
Yeah.
They sound very similar.
Yes.
That they're testing different modules.
Exactly. The simple difference is integration testing has two components that depend on each other, where end-to-end tests actually don't care. Like there could be 20 components until you make or prepare the response that the end user, that the client needs, and the client or the end-to-end test doesn't care about all the integrations. So instead of writing 20 different integration tests, you write a single end-to-end test and just hope that it works. And the rest basically is debugging, which is quite hard. Does it kind of make sense?
Yeah, so integration is between two.
Yeah. Any other questions? Here.
When you're doing end-to-end testing, if it fails, don't you then potentially go into unit testing as well, or can you combine?
That's perfect. Exactly. This is actually, thank you for reminding me. This is actually the approach that you should be taking. Start with end-to-end tests. If they break a lot, and if you can't quite point your finger immediately to where the bug could be, then you can go into integration testing. And if they still fail, then you can go into unit testing to make sure that that thing doesn't happen again. The idea with testing is to prevent something called regressions. Okay, regressions is what happens when a bug occurs again. So there's a bug in the system, you fix it, and 2 months later the same bug occurs again. That's called a regression. Okay, and actually the real value of testing is not in the initial release of the software, but in preventing the regressions, that they won't happen again. So after each bug, you write tests to make sure that bug won't happen again. So you cover the case of that bug with a specific test for that. Let's say people can pay with minus values, with minus deposits, bank accounts. You should prevent that. So you write a test to prevent for that, to care for that, and you make sure it won't happen again. And exactly, that is how you approach unit testing. If your end-to-end tests fail, you start writing integration tests. If integration tests still fail, then you go to unit tests to make sure that it won't happen again. Does it make sense? Another question? Yeah.
You mentioned automated user acceptance testing.
Yes.
You're using your generated
Yeah. Yeah.
Okay. And that was just one of the questions. And then my second question is, so when you're generating this random input, isn't that the same as mock data? Because it's mock data that's going into forfeit, for example. Isn't that the same thing, or what is the difference?
No, the mock data is used in the output. The generated piece is for the input. So let's say you have a database and your application, like we had in our homeworks. The database is the dependency, is what we're mocking. So we are actually mocking the output of the database, like creating a person. We mock it so that we make it seem like we created a person, and we reply as if we are the database. But the random input thing is the age and the name that you enter to that test. So just, for example, if you want to test if like the minimum age for a person, which would be 0, right? If you want to test for this, you could write -5 and test it, -10 and test it, and or -infinity and test it. Random numbers to test a wider range. Maybe there's something that will break. Of course, with an age, it's not that big of an issue. But let's say you're doing a real app like Uber, so you have to track location and distances, for example, of the driver to the user, and you want to test that you can get the nearest driver to the user to propose, because that taxi should pick you up because that's the closest one, which depends on two different numbers, longitude and latitude, and you have to calculate the distance in between and the time that it would take to get there. A car could be further away, but the traffic could be lower, so actually the time to the customer would be less for a car that's further away. So you have to test that this algorithm runs correctly in all the business cases that you defined. There you cannot do with manual testing. There you have to have generated input, because there could be such a city, such a situation. In the case of Uber, you're operating everywhere in the world, right? Maybe in Russia, the roads are, or in Moscow, the roads are designed so that it's easier to walk for people, but it's impossible for cars to get around to a certain street. This is actually something that I manually experienced last week when I was in Moscow. A distance of 1 kilometer by walking is actually 4 kilometers with a taxi, because the roads are so that you cannot turn anywhere else. So you have to, go around and around to find your destination, which you have to make sure to include in your tests. But how do you do it unless you know that there's a city in the world called Moscow where the street regulations, the road regulations are so bad that this thing happens? You call a cab, it shows you it will arrive in 3 minutes because the walking distance is 3 minutes to where the taxi is, but it actually takes 15 minutes because the cab has to go around and around to reach you. So you cannot manually test this unless you do generated inputs. And of course, it may be the case that the generated random numbers will not hit such a scenario, but at least it's more likely that it will find bugs like this or find open areas that you didn't address in your algorithm, which you can never imagine with your human brain, because it's humanly impossible to make it 4 times bigger. 1 kilometer becomes 4 kilometers, which basically kills your business as well, because they will say, okay, like I won't wait. The app says it will arrive in 3 minutes. I've been waiting for 10 minutes and the car is still, somewhere else. I will just cancel that. I cannot take this anymore. I will just walk. This is actually what I had. So like it's an experience that I felt, that I lived, and it could be prevented with proper testing. But apparently nobody cares for this, and they lost money as a result. And I'm just one incident. But that's why generated inputs are important, and that's how it's different than mocking. Basically, mocking is the output. For example, you mock the database to say that, oh, the distance is 3 kilometers all the time, and regardless of your input. That's what mocking is. Any other questions? Please. Yeah.
And on the website, it says if you want to know how to use the API, check out the test code. Is it a common usage of the testing as well?
Oh, perfect. Yeah, thank you. This is really, really helpful for me. So the question is, there is a certain open source library which, instead of documentation, refers you to their tests. So they say, if you want to learn how to use this library or this API, just check our tests. We don't write documentation because it's actually repetitive work. And that's true. That's a common practice in open source libraries or APIs. If they are really well covered by tests, and if the tests are really simple and structured, it gives you more value than documentation because you see real life examples of the usage. Because if you have a documentation, you have a use case in your mind that you want to use that API for, you have to apply that problem to documentation to see how that would work. But maybe in the tests, you will come across a very similar example to what you had in mind, to the use case that you had in mind. Therefore, the solution will be already there. Therefore, of course, it's one of the best ways actually to assess the maturity of an open source solution. If it has good tests, if you can actually look into the tests and understand how the solution is used, and you don't need the documentation, then that's like a dream, actually. So yeah, it's what a lot of libraries aspire to do, let's say. Any other questions? Please. What testing? Front-end? Yes, I didn't do it with Jest or React, but for Angular, for example, with Protractor, and for actually Jasmine for custom JavaScript front-end code. And I can tell you that it's not the best experience. Jest makes it a little bit better because it treats the React components as backend components, let's say. But there I find Selenium more useful, again, as end-to-end tests. Selenium is an environment where you can write end-to-end tests for the browser. So you say, find this button on this web page that says submit, and click it. Or find this input that says email, click it, type this email, find the password field, type the password, find the submit button, and click it. And you should see such a page. Like it has kind of a library that you can write these kind of tests. So it makes sure that the input is there, the input is clickable, and you give it some input, and you click the submit button, and you see the result that you submitted. So again, there I prefer end-to-end tests more, as I believe they bring more value. Because I've seen a lot of cases where again, your unit tests with Jasmine or with Jest in that case as well, they work. The components work themselves. But the users are so imaginative. They put your application in such a state that you could never do yourself, and your application doesn't work. The best way is to imitate a user by writing those automated scripts. Okay, any other questions? This is fun. I like it when you actually talk and contribute back, because you actually come up with ideas that I forgot to mention, which is infinitely in the interest of all of us. So please feel free if you have anything else to say. No? Okay, then we will get to actual implementation and start with what? Yeah, we will have a break, but uh, we will get to the implementation, and obviously we will write a lot of tests today for our homeworks as well. But what do you think we will start with? End-to-end test? Unit test. That unit. But yeah, that's true. We'll start with the unit test because that's the simplest. The idea is to kind of give you the insight of how to write tests. Therefore, we will start with the simplest thing, which is not the most valuable thing. And we will go with end-to-end tests. We will actually skip integration tests because it's horrible. And I will tell you why. But we can have a break for 15 minutes and come back. I have an empty folder called WTMBJS-7. Create an empty folder. Hello. Create an empty folder and open it in Visual Studio Code. I would like you to follow me step by step. Yeah. Yeah. We will do npm init to create a new Node.js project. Okay. As usual, you just hit enter until it leaves you alone. And it gives you a package JSON. You do npm init. Okay. The next step is to install some libraries that we will use to test our code. npm install --save -dev ava or ava. Ava is the name of the testing library that we're going to use, which is kind of the simplest to use testing framework in JavaScript. And it's kind of has some features that runs your tests concurrently in parallel, and it matters when you have thousands of tests. So instead of running them one by one and take 20 minutes, you can actually run your tests in parallel, depending on the number of CPUs that you have, which is really cool. So we will just use Ava to, like, as a start. You hit that, and hopefully the internet will help us here. It will take some time before it installs those. So if you didn't create that folder and do an npm init, make sure you have that. Okay, it took 20 seconds for me, but in the end I have Ava as a development dependency. This is different than what we did before. Before we only did npm install and wrote the name of the library. But now we put in another argument, save dev, which is used to indicate that this is a development dependency. This thing shouldn't be installed in production. So when I actually run my software in production on my server, I basically don't need to test anymore, because hopefully by that time I have tested my code. This is only done when you want to develop something locally, or before you push your code live, or before you push your code to production, you do on your integration environment, continuous integration environment, to test your application. Therefore, it's a development dependency. This thing shouldn't go to production. This is important. All right, so I will start with a very simple module to do mathematical operations. And then I will implement the person class again. And then I will go to end-to-end testing for our homeworks. Question?
Well, yeah, I think actually the question was about what we were talking about before. I was just wondering if there was any specific library that you use for generating automatic.
No,
Okay.
but there are a lot of libraries. I just didn't have the chance to check them out. I use math.random and just randomly do stuff. Okay, so we installed Ava. Raise your hands if you could install Ava. That's good. Let's write a module. Index.js. This is where my code should be, right? I will just create a function called add. You don't have to follow this because I will delete this in a second. So it should take two variables, right? And it should do this, okay? But I actually want to turn this into a library, a module that I will actually use here in the index.js file, because the index.js file is where my code is, where I will do add 3, 5 to test this or to use this function. Therefore, if you remember what we did before, we created another module called, let's say, library, okay? And we did export.add equals something like this. And on the index, what we did was we required the library. This is just a recap of what we did before to get you warmed up. And we did library.add. Let's assign this to a variable called result and log that variable. Yeah. So you get the result as 8. So this hopefully is something that you are all familiar with, to include a library and to make use of that. Okay? So let's keep this index file empty and this library empty as well, because we'll be doing test-driven development, right? There will be tests before we write a single line of code. How do we do that? We usually have a folder called test. So create a new folder called test and create a new file in it called addition.js, because I want to test the addition function that I will write. I will write a calculator. I won't, but let's assume that I will write a calculator. I want to test the addition functionality. So how do I do that? I start by basically importing Ava. This is a weird convention that they are using. They don't call themselves Ava, but tests. So I do import test from Ava. You could also do const test equals require Ava. But this is basically a futuristic framework, test framework, so it's already embracing new import-export syntax, only for the tests, not for source code. So you can actually do import test from Ava. This is basically how I start. The first test that I should write should better put a smile on my face. It should pass, okay? How I do that is I create a test by writing tests. It's a function that takes several parameters. The first one is the name of the test. I will say automatic pass, follow me, please. And the second one is actually the function to run for this test. It's a function that takes a parameter called t, okay? And t has special methods available to you, where it lets you check, for some assertions for your tests. I will talk about those, but currently we are interested in the pass function. So pass means, hey, this is a test that should automatically pass, all right? That will be a green check mark. So who has this right now with me? Okay, make sure that you write this. So I need a way, like this is my first test, and it will pass. I need a way to actually run this to see the output, right? How I do that is I go to my package.json. What was the first function before installing Ava? We did npm init. Somebody wrote it to the Slack channel. And we did npm init and tapped enter until it let us free. So I go back to package.json, and if you see on line 7, there is something called test under scripts. So this is a script that you can run, and it says echo error no test specified. It's like a robot response answer, and how you run it is you just say npm test. This is actually meant to run your tests, but it says error no test specified. So the magic happens when we write, instead of this ugly message, when we write Ava. I run npm test, and it says 1 passed. That's good. There is another syntax, which also gives you the name of the tests that it's running. And it's achieved by adding this verbose command. I run npm test, and you see there's this automatic pass and a green check mark next to that, which means the test is passing. Make sense? Now, I told you that the tests should be running with every single change you have on your source code, which means there should be some mechanism like nodemon that will restart this over and over again when you change your files. Actually, we achieve that by adding another argument to Ava called --watch. The command for installing Ava is npm install Ava. And there's the save dev here. npm install save dev Ava. So I added this --watch here. And now when you run npm test, it will run, but it will not quit. So when you go back to your tests, for example, and set it to fail, you will get this remark here that said, hey, actually, one test failed. Test failed via t.fail. Because I made this actually fail on purpose. So I can actually name this automatic fail. And you see that it will run again. It says automatic fail. All right. These are the first two functions that you should be familiar with. Pass and fail. Obviously, they're not that helpful. They're just there if you want to quickly debug something, or if you want to first give your first set of tests. So let's make this bigger. If you remember, I told you that I will write the tests first and then write the source code to make those tests happen. So what I do is I import the module that I want to test, which is the library, okay? So import library from path, from /library. And I save this. Obviously, it will pass. I want to test the addition, right? Const result equals library add 3 and 5. I want to test if it can add 3 and 5. I should give it a good name, a descriptive name. And the result should be 8. Now, how I check if the result is true is by using some of the functions here. And the function that I'm going to use is called is. And I will say t.is results. The second parameter is the expected value, which is 8, which I know by heart, because when you add 3 plus 5, it will be 8. Okay? And if you want, you can have an optional message. Output should equal 8, for example. And you save this again. Okay, I saved it, and there is an error. Welcome to the world of a software engineer who is doing test-driven development. The idea is to get all these things red and then turn them to green. Okay, it says one test failed, error thrown in test. And the error is library to default.add is not a function. Why do you think we're getting this? Why do we get, add is not a function? Yeah? Yeah, we basically didn't define anything yet. We didn't write a code yet. But I know that I want to make this happen. All right? So I will go to the library and define something here. Exports.add equals something that returns 8. Let's save this. Oh, it worked. One test passed. I made it work. Yay. So I added 3 and 5, and I apparently got 8 works. But obviously this is not really working, right? Let's write another test. I just copy this and paste it to test other input. I will do, for example, 4 and 5. And add 4 and 5, and the output should be what? 9. Yes. Let's save this. Oh, it failed. Why? It says, okay, one test passed, addition, add 3 plus 5 is okay. All right, it's green. And then addition 4 plus 5, output should equal 9. It didn't work. One test failed. Why did you fail? We go down and it gives us a very nice display of where the error is. It says the result should have been 9. And it also tells you what is different. It says, this is what I got as a result, as an output, 8. But this is what you were expecting, 9. So there's a difference here. Obviously, we do it by going back and fixing this thing. Value 1, value 2, value 1 plus value 2. All right? I save it. Now, 2 tests pass. That's good. It works. So I first wrote the test, and then I wrote the code for that. Let's try if it works with negative numbers. And minus 4 plus, I don't know, 99. I'm trying to be imaginative with the numbers. What is the result for this thing? What happens if I add minus 4 and 99? Output should equal 95. I save it, okay. Automatically runs all the tests. 3 tests passed. That's nice. Looks like it can add up 2 numbers. It's very simple. Who followed me so far? Okay, the rest should get to this level. And let's take some time to get you to this level. Yeah, the library is here. I just defined a function there, add, that takes in 2 different parameters and adds them. There's nothing in the index.js. It's empty. But now that I wrote my code, I can actually utilize it here. Const library equals library. You don't have to write this. We will not write nothing in the index.js. But you can do library.add, 9 and 10. And when you run it, you will see that the output will be 19. Yeah, of course. No. Or maybe they fixed it, I don't know. But back then it was not working. Anyway, so you don't have to write anything to index.js. But a good idea was to test it with fractional numbers. So I create a new test. Add 0.1 and 0.2. I pass in 0.1 and 0.2. The result should be what? 0.3. Thank you. Where are the other people? So the result should be 0.3. I save it. Oh shit. It didn't work. Apparently, our addition, which is just doing a plus b, doesn't work for fractional numbers. This is the difference. This is the real result, and this is the expected result. Unfortunately, this is a bug in JavaScript. It's not a bug, actually, because JavaScript doesn't really have different number types. It's just a single type. That's a number, that's a float. And every number, even whole numbers, integers that you use in JavaScript are actually represented as floating numbers. And unfortunately, the standard for floating numbers fails when it comes to some cases like adding 0.1 and 0.2. And yeah, this is the scientific representation. This is the actual value. That is in the IEEE standard. I guess it's 754, I'm not sure, of calculating floating values or floating values arithmetic. Huh? Yeah. Wow. I'm impressed. But yeah, basically, this is the output we humans expect, but machines are not as good as us in adding numbers. So basically, you don't add these values. If you're doing a financial application, you will fail pretty hard with this because this is some of the inputs that people will generate for you. Unless you know how addition works in JavaScript, there is no way you will use 0.1 and 0.2 as inputs because 0.5 and 0.5 works. Only some numbers don't work. So random inputs actually save you here. If you have random inputs, there's a high chance that you will hit this thing. and it will save your life and your business. If you're doing financial calculations, there are obviously libraries that you should use, arithmetic calculation libraries that you should use in JavaScript to make this happen. Okay, but I'm just, I want to fix this. How can I fix this code? Let's say this is the default implementation. I'm gonna fix it. Because I'm a pissed off developer that, whose lead forces him to release to production as soon as possible, and there's this error, so I will just say somebody tell me what I'm doing. What? Yeah. Yay! It worked. Okay. Let's see if this works for another number, a similar number. Oh. I copy it and paste it. This time it should be 0.3 plus I don't know, 1.3 or 1.1, whatever. Just guessing stuff, random. What is the expected result?
1.4.
Thank you. All right. Oh, no, it failed again. Okay. This is something that you cannot work around, and obviously you shouldn't do this. Okay. It's not allowed. Actually, there's a urban myth in software engineering where people claim to have seen the first versions of PlayStation code for random numbers, generating random numbers, and math.random should give you a random number every time you call it, right? And the code is just return 4. This is a myth that's been going around, and I'm pretty sure it's not true, but who knows? So developers actually like to do hacks like that. If value is this and value 2 is that one, just return the expected output. Obviously, it's not as easy as this, like in addition, but in certain cases, when they cannot find a real solution, they actually resort to those bad practices. All right, so I want to show you another feature of Ava. And that is checking for arrays. So numbers is easy because you can use the equals operator. You can say, if 3 equals 3, that's fine. But if you pass in, let's maybe try it here. Again, you don't have to follow me. So this works, right? This will give you true. 3 equals 3. But this won't work. An array of 2s. The second one won't work. It will give you false because these are actually different arrays in memory. Although they look very similar, they have similar items, it won't work. So I add a new function called push to array. You can follow me. Let's take in an array and an element, and we will do array.push element. Okay? So, did you notice something? Something different with my approach?
You wrote the code first.
Yeah. I wrote the code first because honestly, this is enough. I'm fed up with test-driven development. Because I know the code that I want to write, all right? So this is something called push to array that I will test. I will delete this thing and this thing also because there are anomalies in my code. I will do tests push, 3 to an array. And this is the function that will handle that. What should I write here to test this? How do I test this code here? What? T dot something is used to check for the results, which is called an assertion. We use it to assert something and to see if it's true. So I already import the library here on top. And I want to test this. What do I write to test this function if it works? Yes. Thank you. Actually, I can do it like const results already and say library dot push to array. Okay. Give it an array, an empty array, because it receives an array, and 3 as the element. All right. So again, I use is, right, to check to check for the value. What is the first parameter? Result. What is the second parameter? What? Array with 3, right? You don't actually have to have the third parameter all the time. If that's trivial, you can skip that. Let's run npm test. Okay, one test failed. Push 3 to an array. Why did it fail? It says 1, but I was expecting an array. Why did this fail? This is the length. This is good debugging skills. You should think, hey, what is 1? What can be 1 here? There is nothing 1, right? Like there's an array, there is another element, but no 1 anywhere. The only 1 there can be in this mechanism is the actual length of the array. Like the thing that I'm passing in, one single element, that's what 1 is, the length of my array. So actually, you're right, array.push gives you the length of the array as a result. So actually, this code should be return array. If you do this, you still see that it fails. Why? Any ideas? No, but it's kind of frustrating, right? We think we fixed it. Return array, like what do you want? Let's log it. With a message so that the Cosmos understands that we're pissed. Hey, why did you fail? I save it. It ran. Interesting. This is actually, it gives me the array that I was expecting, kind of. Hey, why did you fail? And it printed this array as the result, but it still fails. Why do you think it fails? It's kind of messing with me. No.
Could it be possible that we cannot compare two arrays like this?
Why not?
Maybe, I don't know, maybe
You're right. Please remember the index file that I wrote. You're not following the class. Come on. I told you that you cannot compare two arrays. That it's never possible. You can compare the individual elements in an array, but you cannot compare two arrays because the references of arrays are different in the memory. It's an advanced topic why you can't compare them, but it's enough that you know you cannot compare arrays or objects with an equal sign or equality check. This is why this t.is is failing, because all it does is pretty much this. It tries to compare them with an equality check, and it fails. Actually, it's trying to do this. But, all right, how do we fix this? There is another function in T called deep_equal. When you save the file and run the tests, you see that it passes. What deep_equal does is it takes two different objects, arrays, whatever, you give it to them, you give it to it, and traverses all the elements in those arrays or objects again until it finds the final element. And in this case, we have only one element, that's 3. And it basically compares those one by one. So, you know, if we had another element here, this would be 10, 3. So it checks all the elements, compares them one by one, and tries to see if they are equal. You could also use an object here. You don't have to follow this, but you can also use an object here, and it will still work. Although these objects are totally different, you can still compare them with deep_equal. So this thing, this API, deep_equal API, is what you will use maybe 90% of the time when you're writing tests. Because, again, we will do automated tests, automated acceptance tests, which means we will be dealing with API responses all the time, which will probably be in JSON, which is an object. So how do you compare the results? You could do it field by field, by hand, by using t.is, or it's a lot easier to just use this object here. All right, so raise your hands if you could follow me so far. That's perfect. Yes, yes, thank you. So it's as simple as this. You will see that people are using a lot of other libraries, a lot of other approaches. You know, there is a library that I won't mention, which allows you to do something like results.should.not.equal, and it's a function, and you say this, you know, results should not equal 10. Which is very convoluted because, you know, how do you know what comes after this? You can actually omit this, should equal, becomes this. This is very convoluted. They do this in order to make it simpler to read, but I find it harder to read because I'm always confused, you know, like what can I write? Should I have to put should here? Why is it not could? If it's a language, you know, or why is it not maybe? And then there's another grammatical error. If we try to make it look more like a real language, this should be equals, not equal, right? But when if it's people, then it should be equal. It's weird. How do you know which one is there? This is something that I cannot use, and therefore I don't use those libraries that you may find online. That is, you know, recommended for JavaScript testing or any other testing environment. What we do is we use t.is to check for equality. We use t.deepEqual. Okay, there is the inverse of is, which is t.not. So it checks the values are not equal to each other. There is t.true. Okay, something that you can use. T.true is actually using t.is. The first value is the result and the second value is true. So that, I mean, you don't have to write this. You could use either this or you could use this thing. Like these two lines are equal. Obviously, there is also t.false. Okay? These are very, very primitive constructs that you use to make assertions, to make assumptions and to validate your assumptions with the expected results of basically your code. And I guess there's also t.not deep equal. Another one for t throws to check whether a function is throwing an error, throwing an exception. And, you know, not throws. Very, very simple, okay? Really simple. And basically you combine these to validate your tests, your results. And this is almost everything that is related to unit testing. You have units that you want to test the inputs and outputs for, like addition, or, you know, generating an object, pushing to an array, and then you test them. So I told you that I will do a person example. You don't have to follow me, but watch me, because I will type really fast. Exports person. This is a class that I'm exporting, okay? It will take a name and an age. This is the same thing we did since the beginning. This.age, all right? And I want to test this. So test create person, all right? I create a new handler. I had imported the library already, so I do const person equals new library dot what? Person. Why are you so shy? I mean, it's apparent, right? It's person. New library person. And what will I type here? Huh? Louder. What do I type here? A name. Yes. And an age. All right, so I created a person. And I want to check if it's able to set the name. So t.is person.name, and the second parameter is again Arman Amcalar, and t.is person age equals 33. Okay, it passes. If I had a typo, like some of you did in your examples in your homework, like this, you will see that it won't work. Person age failed. create person, failed. We want its age to be 33, but the age is actually Arman Amcalar again. Then you go back to your code, you see, oh, actually, I'm doing wrong here, so I will correct it and it will work. This is why test-driven development is important for beginners, because you do a lot of mistakes when you copy-paste code, when you write something, but you actually know by heart how you want to use that functionality, how you want to use a function. You know the inputs that you want to give to it, and you know the expected output. So it makes more sense to actually write the test first, and then the functionality. And that's what I'm going to do next. I want to implement a new feature, a totally new feature that we didn't do before, which is to grow or get older. Okay? And I will write the test first. This is a test to check if a person can grow, can get older. All right? Now, the best practice of tests is they don't share any state, any code, any property with other tests. It's a clean slate that you start from scratch with each test, okay? So you, again, create a new person. There's no way around that. I mean, of course, there are ways, but it's a bad practice. You always start with a clean slate. Let's say Miri Minas. So, okay. I saved this and it said test failed, get older, because there were no assertions here. All right? So, I think I'm going to use is. What should I type here? I want to make a function, make an implementation to, make Miri older, like 1 year. I will call a function, and as a result, Miri will be older. What should I type here? Person, +1. The expected output. So you say I should write person.age +1, and the second parameter is 30. This is actually implementing the feature. This is not the test, but I'm on the test side. So I actually need to run the function and check its output. Sorry? No, we first have to write the test for it, which forces you to think about your API. How will you implement this? Yeah, what do I type? Yeah. Yes, person.age, 30. I save this. Obviously, it will fail because the age is still 29. There's something missing. What is missing? I didn't call any functions to actually make Miri 1 year older, right? I should be calling something. What is that? What? Birthday? Could be. But it has to be a verb. So get older could be, or grow. I don't know. I actually don't know the English word for this. If there's any native speakers, please tell me.
Age should work.
Age? No, that's terrible. Because we have it as a property, okay? No. All right, let's say grow. So I save this, and then it says, oh, sorry, not t.grow. It's person.grow. It says person.grow is not a function. That's expected, right? What do? I add a function here, grow. What will it do? What plus 1?
Each plus 1.
Age plus 1. So I save it. It says age is not defined. What? This dot age. Yes. This is actually how you solve it. And it didn't work because you need this. This age equals this age plus 1. And it passed. Okay? Now, I know that Miri actually can get older now. So that's nice. She's not stuck at 29 anymore. So 2 years pass, and there's a new CTO who's very ambitious and says, we will refactor everything and make our code base perfect. And is, very detail oriented, let's say, and basically obsessive. So sees this code and says, you know what, actually there's an easier way to write this. Like, this is not the best way to write this. There's actually an easier way, an easier syntax. And I want to change that. Okay? He comes with a million requests like this in every single class that you write. And as a developer, you are forced to, comply and make the change. Now, first tell me, what is the simpler way of doing this? Yeah, this age plus plus. Okay, I made this change. And I made a similar change in, 1,000 other classes. I have a huge change list. How do I make sure my application won't break? I had a test for this function. And, I can do this with my eyes closed. I refactor my code, and it works. I know that it works because I actually tested it before. There's a test for it. And you can do anything you want. Basically, tests give you the ability to refactor your code anytime you like without any concerns, any doubts about the execution and validity of your code. So it's why it's important to have tests for everything in your code base. So it's not like you're doing it because your lead asked you. It's not like you're writing tests because it's fun, because it's the best practice, but it's actually to save the future. You're saving either your own future from trouble or a future colleague from trouble. There's actually a very nice quote that you should learn and apply by heart. And it says, always write your code in such a manner that the next developer who will maintain your code is a psychopath serial killer and knows where you live. Okay? Always make sure that your code won't piss him off, that he will not come after you. And it actually holds. If you give that much attention to your code, and obviously tests are a good way to do this, then that guy won't come and kill you. I promise. This will save millions and millions of dollars or euros in your budgets. That's why everybody wants to do tests, but they don't, and they can't, because they are actually overcomplicating it. But this is the beauty of unit testing. You tackle each unit on its own, like grow function, person class, very, very simple. And it's really easy to actually ensure the output is correct. If you don't run into trouble of adding 0.1 and 0.2, which you can never measure. But okay. Now this is all I want to tell you about unit testing. And then finally we will move on to end-to-end tests with our application, with our example application. where then we will talk about a little bit more details about Ava. Okay, you can put this folder to a side. There's another folder that you were working on before, that we were using as a test bed before, my repository on GitHub. I hope everybody has it cloned, WTMBJS-4. We used this as an example in our previous classes. So you should be on the master branch, or we had a branch called week 5, where you may have done some additions, some changes. So you should check out the, first you do a git pull to get the latest version, the latest branches. There's a new branch called week 7, which we will use. And after a git pull, you do git checkout week 7. And this is basically the bed that we will use today. Raise your hand if you need help. Obviously, we have instructors here. Anya? Anya? Are you here? You may need to do npm install after you check it out. Do an npm install so that you install the dependencies. And then run npm tests. So you should see something like this when you run npm tests. That looks cool, right? That is called code coverage. But I will just go on with the presentation. If it doesn't work for you, just watch me. If it works for you, and it works for some of you, that's good. Like, you get the tests passed and then the result. All right? I will show the tests that I wrote here. This is the application from week 5, the same application. We have the person model, we have the person roots, okay? The same application, which also includes the friends functionality, all right? So this is something we already did before. The only thing that's new is there's something called app.js, and there's a difference in index.js. If you remember from the previous example, index.js was, longer. It had more lines in it, and it actually included what was here, like this file. But if you notice, here I put it out on a different file, a different module called app.js, made all the configuration of Express application here, and exported it as a module, okay? There is no listen command here. I'm not doing app.listen here. The app.listen goes to index.html. So when I run this, it actually works, and you can go to port 3000 on your browser and it will work. But when you test it, you can actually treat this app as a module, as a black box that doesn't really listen to a port, but you can still test its functionality. So this is the first thing that you do. When you're testing an Express application, you don't listen to a port, because you'll run maybe 1,000 tests in parallel, and there's only one single 3000 port, right? So you abstract away the application as a module, And in your index.js, you require that, and there you call the listen. This is what runs when you call node index.js and starts the application normally. But then you can actually, if you go to your tests, you can import your test here. Okay? Sorry, you can import your application here and then test it without actually listening to a port, without binding to a port. Because again, there's only one port that you can bind to, 3000, and probably you'll be running more than one test. Hopefully, you have more than one test. So a single port will not cut it. And you can't actually change the port address manually. It just doesn't work. So the idea is to abstract away the application as a module and import it here. So I wrote some tests for you that I will go over. So please watch it. So get list of people, for example, is a test. What do I do to see if I can get the list of people? I create a person, and this is the object that I use, that I will create. I call it person to create. If you remember from our Chrome test, we wrote something like axios.post person, right? And then we would pass in name, Arman, and blah, blah. This is basically the same thing. So we could do person to create here, and it would create a user. But here we are using something called a super test, a library called super test that has functionality to ease testing with Express applications. So it actually wraps your application, your Express application, and lets you call the root handlers as if you are doing real calls. I mean, it's doing real calls, obviously. But you know, it's a nicer way so that you don't have to use Axios. You could just as well use Axios here if you had another application to test that listens to a port, for example. But so this is an asynchronous operation. This is the syntax that we use, request, and then that's a function that takes your application as a parameter. So you do request app, then post person, and this is the syntax to send an object. Basically, this line is exactly the same as creating a person with Axios, just a different syntax. And this is a request, okay? And then what I do is I get the list of people that I want to check. Now, why am I doing this? The first time I get the list of people, the database could be empty, or the database could have 10 different users, right? I don't actually know. Maybe the database don't really even exist. So in order to make sure that there's a database with at least one person inside so that I can get their details, I first create a user. I first create a person. And then on the next lines, on line 12 and 13, if you remember, this is the API that will give us the list of people as an array. And then I get the results, the actual result that I want to test. So first, I'm testing to see if this was a successful operation. The result of the response, the status code of the response is 200, which means, okay, this was a successful operation. Or it could be 404, which means there is no such a person. And actually, we will make use of this when we try to delete a person. So I first make sure that this status is correct. The next thing is I make sure result body is an array. Okay? I got the list of all people and I make sure that it's an array. And there's a message here, body should be an array. If this is not an array, it will fail. And the next thing that I'm doing is, now that I know I put at least one person in the database, the length of the result should be greater than 1. Sorry, greater than 0. So there should be at least one person in the database. Now, this is an end-to-end test. I cannot ensure the database will be clean every time I run this test. And maybe I also shouldn't, because your real-life systems will be depending on a previous state. You will never run with a clean slate. There will always be previous state. So your tests should actually cover for that scenario. Like in this case, I could have 10 different people in the database whose details I don't know. So I can't actually do a t.deep equal here and say rest body equals, person to create. If I had started with a clean slate from scratch, with a clean database from scratch, I could actually write this. When I get all the people, it's an array with the first person that I created. This could work. It wouldn't work, obviously, because there are other fields in the actual response, but this is the idea. But I can't do this because I don't know how many people there are in the database. So all I can do is I can check, hey, this is an array, and the length of the array is bigger than 0. A further thing that you could do is you could try to search for the person in the response so that the name and the age matches, so that there's a person that I created. But it actually is not the point of this test. It is the point of creating a person. The point of this test is just to check that you can get the list of people, which could be any number of people. So as long as it's the result is bigger than 1, it's kind of fine. The next test is to create a new person. Again, I have a person to create, okay? I post the person, again, the same step. And I get a result, I check this. The next thing I check is the name of the person is actually matching my criteria. And the age of the person that I created is actually matching the person that I could create. Now what this does is this calls the backend API that I wrote before. It hits MongoDB, creates a record in the MongoDB database. Then the API actually returns the result, the created person, and I get that and I check the fields. For me, this works. If this test passes, this means I can create a person. Getting the details of a person is another thing, all right? And again, I create a person. This time, there's a difference. I'm not interested in creating a person anymore. So the result code of person creation is something I don't need to check for. Therefore, I skip that part. But what I care for is the result code of the fetch operation, if I could get that person details. If you remember, the URL for that was person/person ID. That gave you a web page in Chrome, and I kind of did a little bit, a workaround here. I added a new root handler that I actually forgot to show you, but it's very simple. So this was the page that we wrote before, which rendered the person detail web page. I just made sure that it also gives me JSON, so that you can get the details of a single person in JSON. Okay, I just added a new root handler, and all it does is just returns me the actual person details instead of putting it in an HTML. Okay, so I want to know if this thing succeeded, so I check the status code. This is something that you have to do every time for HTTP APIs. You have to check the status code is 200 and nothing else if you want to test the success. And then, here's the magic. I say, I'm checking for deep equals. The body of the response, like the person, should exactly match the person that I created before. And this is doing field by field matching. It matches the ID, the underscore version that MongoDB created for me, if you remember those additional fields from before. And it makes sure that this API, this get API, which is what I'm testing, fetching a person, is giving me the correct person field by field, the exact correct person. So I create a person because I tested this, right? There's another test for this. There's another test that checks the creation of a person. The creation of a person is correct. I know that already. If it didn't work, this test would fail. If this test passes, I know that this thing will pass. So I know that I get a legit person. I can create a legit person. But let's see if I can really receive that legit person. This is another endpoint, another route that I wrote. Okay? And I know this was already passing, this was already successful. I test this by saying, hey, tell me if you're actually that person. And I do that with deep equals. Again, is won't work here because these are different objects with the name, with the same fields, with the same values of the fields. Deleting a person. Again, obviously, I'm creating a person first, right? Why do I do this? Because I don't know if there are any people in the database. I don't know the IDs of the people in the database. And in order to delete a person, I need an ID. So I cannot say delete the first person. What if the first person is already deleted in the database? I can't know. Therefore, I create, again from scratch, a new person, put it in the database, and then I try to delete that. And see, this is the request that I'm making, and it's giving me the body, which is the person, the actual person is created here as this variable, the person variable. And it has a field called ID, which is auto-assigned by MongoDB, by Mongoose. I didn't write the ID here, right? I didn't give it an ID. This ID is generated by the backend, which is legit. So I just created a person, and now I want to delete this. Again, I know that this will succeed. I can successfully create people. I know for 100% sure that that will work. But I'm not sure if the deletion will work. And so I want to delete that person. And first I also check the status is 200, that I could delete a person, okay? And the result is this text. This is how we implemented the deletion. If you look at the handler, we just say, okay, as a string. So the way to test is like delete request.text equals, okay? And finally, how do I make sure I actually deleted that person? Try to find it again. Now I know from my previous tests that I can actually find people. And there are no problems with finding people if they are existent in our database, right? A person may not be in the database if I deleted it. So I first create a person, then I delete it, then I try to get that person again. If that person is there, then my code doesn't work. If that person is not there, then my code should work. And how do I test it? I test if the status is 404. Does it make sense? Because 404 is what you get on web pages when there are no resources with that URL. I want the JSON of that person, and the result is 404. No. When the server is down, you get 500 or any other response that starts with 5. 4 always means the problem is with the user. For example, you're asking for something that doesn't exist. Or sometimes you get 400 directly, which means bad request. Your request is, in a bad structure is not something that I expect. Numbers that start with 500 are errors of the server, are errors caused by the server. Numbers that start with 400 are errors caused by the user, by the client. Is this clear? Yes, t.plan. So if you see, this is an asynchronous work, right? We're doing asynchronous operations here. I say that I'm planning to have 3 assertions, not 2, not 4. And t.plan makes sure that I have 3 assertions. So if I put 4 here and run the test, I will see an error. It says planned for 4 assertions, but got 3. So it's an additional mechanism to make sure you actually implement what you said you'll implement. And it helps with the asynchronous work. Sometimes, that callback never gets executed. If you don't have, let's say you have 3 tests, 3 assertions, right? And you run it, and everything passes. Then you delete this 1 assertion. Or let's say it was something asynchronous and just didn't work, didn't execute. You still run it, and it still works. So how do you tell Ava to just wait for all the assertions to finish. You say, okay, I plan for 3 assertions. Just make sure that you have 3 assertions before calling this a successful operation. And now when you, like all of them passed, when you delete one of the assertions, it will just say, hey, like I was planning for 3, but I got 2. So there's something missing. So it's very useful in asynchronous operations. Any other questions? Yeah.
So in the test we're making actual requests to the database.
Yeah.
Does that mean whenever we run the test, we're moving the database with our test data?
Yes. Therefore, you have to use a special database for this, which is another whole topic. Another question? Raise your hand and ask me your question. Is everything clear so far? That would be quite impressive. Of course, everything is not very clear, but we have actually 10 minutes. Maybe we should wrap up. So I wanted to demo how we write the test for making friends. If you want, I can do that in the remaining time. Or we can do it next week as well, before we start. That's totally up to you. Like if you have a couple of more minutes, maybe it will take more than 10, maybe 15 minutes. Okay. All right. It's actually pretty simple. Again, there is a pattern in the way we are doing these classes. Okay. And the pattern is I try to give you all you need to know in order to build real-life applications. And with testing, again, this is everything that you need to know about testing, writing tests. There is nothing else in, methodologically, there's nothing else in writing a good test. You create some records, you do something, you check if the result is correct. That is as simple as it is. And now we will we will make use of the make friend functionality in our tests, and basically we will just employ the same tactics. But before that, I wanted to show you the table actually, this table that we never talked about. So we saw the tests pass, but what this table gives you is code coverage. So it gives you, 83% of the lines in your application are covered by your tests, okay? And it says, 100% of the database connection file is covered. 100% of the person model is covered. That is perfect, which means I tested all the functionality of my person model, all right? That is perfect. Or 100% of your service is covered. What is not covered is the person.js root file. And it actually even gives you the lines that there are no tests for. Like line 35, line 37 don't have any tests. Let's check what those lines are. I go to person.js roots, line 35, 37, 38, 39. They're all in the friends root handler, which is the one we use to make people friends with. So this tells me that I actually tested every single functionality of my app, but making friends. You see, I just wrote 4 tests to cover all the functionality of my app. And it's just kind of repetitive work. Like in every test, I create a person and I do something with that person, right? So it's very simple. This is the beauty of end-to-end tests. They are very, very simple and they are very effective. Each test checks and makes sure your lines are working, and it does this for 100 lines. Each test actually covers many, many lines. So you just write one test and it covers your root handler, your service, your model, your database, your express application. That's perfect. With unit testing, you have to have separate tests and multiple tests for each of these. So this is the beauty of end-to-end tests, or ease of use of end-to-end tests. Okay, enough talking. I need to write the tests for making friends, all right? How do I do that? Just guide me, because I told you that there is nothing else to this thing. I start by writing tests. And I give it a name, make friends with. This is an asynchronous test, so I have to write this async keyword, as we always did with functions before. Okay? Don't worry about the plan, we will later put it in. What do I start with? Create 2 persons, that's great. Exactly. So let's say const person1, okay? The syntax is a little bit convoluted, but you will get used to it. Fortunately, await, request, app, and we do a post, right? Person, send. Okay, I'm just copy this from here. We send the person and the body. This gives me a person, all right? Now, what am I going to do next? I'll create the second person. Oh. What? Sorry? It doesn't matter, I just create a new person. As long as there are no unique checks for the name. If there are unique checks for the name, you have to come up with, again, random names or creative names. Mm-hmm. Yeah. I'll just copy you. Okay. The second person, I paste the second person again. This will be person 1, this will be person 2. Again, I will create Miri. I'm creating you from scratch. Okay, I have the second person. What am I going to do now? I have 2 people. How do we make friends? Axios, and we use a similar thing here. This is the call that I will use. I do, the same thing. Await requests app. Post. Person. This is backticks because I will write the person ID. What do I type here? Yes, person1 dot ID slash. No, the API is friends. So I write friends because this is the API that we defined. The root handler, if you look at it, is ID and then friends. And you see there is a body that needs to be passed in that requires a target ID. The target is the person, the second person that I want to make friends with. Okay, how do I send that? I do send target ID, right? What do I type here? Yes. Yes, thank you. Person2.id. So this should make them friends, right? This is what I expect. So what is the next thing that I'm going to do? How do I ensure that these people are friends?
Test.
How do I test it? What is the way to test if these people are really friends now? Where? Yeah, but like, will this work? T dot, let's say deep equal person 1, friends 0. Let's say that will give you the first friend. Will this work? Should it? What is person 1? Person 1 is the person that I created from scratch who had no friends. And then I created another person and I made them friends. Let's say the previous state of person 1. What I need to do is I need to fetch person 1 again with the updated values, because then I will know for sure that that person has friends. Why? Because I know that I can fetch people already. The other test already ensures that I can fetch people, which means if I basically copy this, okay, again, and let's call it updated person 1, and that is get person slash person1.id, right? Obviously this should be backticks. Okay, I'm not sending anything. Oh, also /JSON so that we don't get the HTML but the JSON version. Now I check updated person 1 friends 0 equals person 2. We created a person from scratch, so he had no friends. We added a friend and we check if they are friends. Let's run this test. So this was the previous case where these lines were uncovered, right? Hopefully we didn't do any mistakes in the code. Ooh, this is nice. I get the test, make friends with. It's running. And check the uncovered lines. They are gone. Now it tells me these lines are uncovered, and the line coverage actually increased, and my whole code coverage also actually increased. There are different categories: lines, functions, branches. These are if-else statements or switch case statements, and other statements that are in the code. All of them are relative, but even if you get 100% on all of them, it doesn't mean that your code is safe. It means that as far as you could think in terms of test cases, your code works, but there will always be a genius user which will prove your application won't work. But anyway, I got my lines covered, the old lines covered. So now we make sure the people API just works. Let's see what those lines are. Ah, okay. Getting all the people, we didn't implement that. /all, the HTML version, right? We implemented the JSON version, but not the HTML version. And also the person detail, the HTML. We could actually also test this by copying and pasting the output on the browser and checking for the text, just like we did in for deletion. We check the text here. You know, when it's a JSON, it's sent in the body, so you check for the body of the request, of the response. When it's text, when it's HTML, you check for the text property. And like if you wrote the HTML here, you know, like this kind of thing, body, person 1, whatever, obviously you wouldn't write it by hand, but copy it. If you write this, you can also check the HTML output, which is awesome, which means you can check every single line in your code base. Okay, does it make sense? Anybody? Does it make sense? One. Anyone else? Not really? Okay. Hopefully the recording will be online tomorrow so that you can see these things, or maybe tonight, and go over the material and work again on your projects. If you can guess what the homework is, this time it's pretty hard, not in terms of complexity, but in terms of amount of work. I want you to get 100% line coverage in your projects. Which means, test all the endpoints. No unit tests, only end-to-end acceptance tests, just like we did right now, all the API, and get 100% line coverage. You will run into trouble. Let's talk on Slack for why some nasty lines refuse to be covered, and we will solve them. We will need to be very creative to get 100%. I only do it once in my life. On real life project, it's impossible. So the goal for you is to get it as high as possible. Aim for 100 and you land somewhere between 95% and 100%. That will be fine, okay? And next week is the last class. We will learn how to deploy our applications to a server, to a real life server, so that people can interact with our applications, mobile apps or web applications. So it will be super fun, but it will also be challenging. I will send you some documentation that you need to follow before you come to the class. You will need to create accounts on DigitalOcean and Docker Cloud in order to be able to deploy your code. It's totally free. You won't have to spend anything, but DigitalOcean requires your credit card number, which could be a problem. If it's a problem for you, let me know beforehand and I will arrange something else for you. But again, it will not charge your credit card. You will actually have $20 to spend, which is enough for about a year, or no, actually it's enough for 4 months of server usage, which you can try out. And hopefully we will end the class with a nice application that we can demo the next week on our graduation party, let's say. We will have a very, very important guest, Christian Heilmann, who is one of the most renowned JavaScript developers in the world. He will have a speech here. And we will also demo your projects. So I guess we will also maybe have some companies who are interested in, basically, in you to hire. I hope that it will be a nice event. I'm looking forward to that. We'll have a lot of fun together. And yeah, thank you again for listening to me, and see you next week. But there's an announcement. The NDAs, you need to sign the NDAs, of course. If you didn't sign the NDA today, just get a paper, it's on the table, sign it, and hand it in to Vlad. And we have the feedback wall back there. Please write feedback about how we are doing. Anything else?
So this homework would be from week, we're using the week 5, right? And then they test from week 5, right?
Sorry?
For the homework this week, we should use what we did in week 5 and then write tests for that?
No, just your last projects, your current projects. Because a part of deployment is testing. We will deploy our applications to the cloud, and in order to know that we are deploying the right application, we need to test it. Therefore, your final application that you present in the graduation or like whatever you're working with could also very well be your homework from week 5, but some people have different projects than homework. So write the tests for your projects that you will present so that we will have a final feature with automated testing before we deploy your code to your servers. And we will achieve that in 3 hours next week, which will be maybe a world record. But actually it shows how simple this thing is. And you'll see how companies make this thing very complicated in their setups, which is similar to testing. Like, again, this is everything you need to know to test your applications. This was a real-life application, we tested it, there's nothing else. There's nothing else that you need to know in order to test your applications. So next week it will be deployment again. That's nice. I will show it quickly. It's a library called NYC, New York. Because you won't believe it, but the default library to check for code coverage is called Istanbul. This is kind of a a branch of Istanbul that is suitable for asynchronous tests and is used with Ava. So in the test script, you write nyc before Ava, and it's a package that we install, npm install nyc. And this is all you need to get that table. And yeah, that's all. Again, thank you very much for today.